All right, page 463 today, and we're looking at example number 4 there. So we're going to be working today more ratios and proportions. All right, example 4, car ownership. Fernando conducted a survey of 50 students driving to school and found that 28 owned cars. So 50 people driving, 28 owned cars. If 755 drive to school, predict the total number of students who own cars. So what we're talking about here is a beginning ratio of driving to owning. Driving to owning. That's the ratio that we're dealing with. So if we set this up as a reminder here, and then we write a proportion, then our proportion is going to look like this. All right, a fraction equal to a fraction. So the given information says that 50 students driving and 28 owned. So driving to owned is 50 to 28. Okay? If 755 drive, so now our numerator in this fraction on the right is going to be 755. And what we're looking for is predict the total number of students who own cars. So we're looking for the number of students that own cars, and I'm just going to use the variable x. So that's our setup for this proportion. And then yesterday we solved these proportions by crisscross multiplying, and we're going to do the same thing today. So right here we take 50 times x, and we get 50x. And it's going to be equal to 28 times 755, which is 21,140. And then divide both sides by 50. And we get 422.8. So we can say that about 423. 422.8, and the question was to predict the total number of students who own cars. So our prediction would be 423. Everybody okay with that? Take the information, determine how you're going to set up your data, and then just make sure that if you have driving in the numerator of the first fraction, that you have driving in the numerator of the second fraction. That's the key to setting up these proportions. However, if we would have set this problem up owning over driving, all right, we would have still gotten the same answer as long as whatever we put in the first numerator, whatever quantity, the driving quantity in the first one, it's got to go in the second one. All right, so let's look at the guided practice down in the bottom of that green box. Biology. In an experiment, students netted butterflies, recorded the number of tags on their wings, then released them. So we're talking about butterflies that were netted. The students then netted 48 butterflies. 3 of those had tagged wings. Predict the number of butterflies that would have tagged wings out of 100 netted. So our ratio is going to start off as netted, and we're talking about butterflies that get netted, to tagged. Netted to tagged. So the given data is that the students netted 48 butterflies. So they netted 48, and 3 were tagged. So 48 over 3 is equal to, predict the number of butterflies that would have tagged wings out of 100 netted. So out of 100 netted, how many are going to be tagged? So I'm using T this time. So there's our proportion, and we set it up using the ratio netted to tagged. So we're going to crisscross multiply again. So our 48 times T is 48T, and it's equal to 3 times 100, which is 300. Divide each side by 48. And 300 divided by 48. 6.25. So our T here is equal to 6.25. And you're asked to predict the number of butterflies, so we can say about 6. About 6 out of 100 netted will have tags on there. I believe they put the tag on their leg, ankle area. Wait a minute, do butterflies have legs? Where would you tag a butterfly? In the wing? Wouldn't that make them fly sideways? It would weigh one wing down, they would fly in circles their whole life. I think it's birds that they put the tag around their legs. They're a little stronger flyers. Okay. So is everybody okay with setting up a proportion? I'm pretty confident you guys can solve the proportion. But again, our initial ratio was netted over tagged. Our first ratio, netted over tagged. If we do netted over tagged, we have to do netted over tagged. That's the key. Okay? Netted over tagged equals netted over tagged. And that's why I like to write it down next to where I'm going to write my proportion. And then double check that I put netted in both denominators and I put tagged, netted in both numerators and tagged in both denominators. All right, and then I just wanted to review the angle problem that we did yesterday and the side problem that we did yesterday. So I'm going to look at problem number 13 on page 464. On 464. So here we go. The ratio of the measures of 3 sides of a triangle is 9 to 7 to 5. 9 to 7 to 5. Ratio of sides. Now remember that ratio of sides is different than ratio of angles. If we're working with the ratio of sides, then somebody needs to tell us the perimeter. Okay? The perimeter is 191.1. Perimeter equals 191.1. Find the measure of each side. So what we're going to do is we're going to take, I'm not going to draw the triangle for this problem, because all we got to do is take this extended ratio and go 9x plus 7x plus 5x and set it equal to the perimeter, because we're dealing with sides. The perimeter is 191.1. And then we're going to combine like terms. All right, 9 and 7 is 16, plus 5 more is 21x is equal to the 191.1. Divide both sides by 21. And our x Our x represents our multiplier. 191.1 divided by 21. 9.1. So x is our multiplier, and our multiplier is 9.1. That means we need to take each of the numbers in this extended ratio and multiply it by 9.1. So one of the sides is going to be 9 times 9.1. Another side is going to be 7 times 9.1. And the third side is going to be 5 times 9.1. All right, so then it's just a calculator problem from there. So we got 81.9 for one side. Uh, 63.7. And then we got 5 times 9.1. 45.5. So those are your three sides of that triangle. And then one more time, I'm going to do number 17 on the top of page 465. Question is the ratio of the measures of three angles, 3 to 6 to 1. Find and measure the angles of the triangle. All right, so if the angles are in the extended ratio of 3 to 6 to 1, we're talking about angle ratio. All right, when we were dealing with side ratio, we needed to know the perimeter. When we're dealing with angle ratio, we know that the three angles need to sum 180, right? So our equation is 3x plus 6x plus 1x is equal to the sum of the angles of a triangle. All right, and the sum of the angles of a triangle is 180. So 3 plus 6 is 9, and 1 we get a 10x equals 180. Divide both sides by 10. We get an x that's equal to 18. X is what we call a multiplier. So we've got one angle that's going to be 3 times 18. Another angle that's 6 times 18. And that third angle is 1 times 18. So our 3 times 18 is 5.4. 54, I'm sorry. Our 6 times 18, 108. And 1 times 18 is 18. Everybody okay with that? Now, if they change this, okay, and let's say they gave you a ratio, let's do a quadrilateral. How many sides does a quadrilateral have? Or I'm sorry, how many angles does a quadrilateral have? It's got 4, doesn't it? So let's say the ratio is like 1 to 3 to 4 to 5. Quadrilateral ratio. And we're going to say angles. All right, we would take 1x plus 3x plus 4x plus 5x. And we wouldn't set it equal to 180, right? Because the sum of the angles of a quadrilateral is not 180. The sum of the angles of a quadrilateral is 360. So we would set this thing equal to 360 and then solve for x. Okay? If they told you the shape was 5-sided, all right, pentagon, then you would find the sum of the angles for a pentagon to set your equation equal to. Remember that? Remember the formula for sum of angles? Sum of the angles is always equal to number of sides, n minus 2, n represents the number of sides, times 180. So if they give you a shape other than a triangle, and they're talking about the ratio of angles, make sure that you get the correct sum of the angles for the shape that you're working with. You're not going to use 180 every time. The sum of the angles is directly influenced by the number of sides of the shape. All right? So any questions on any of those examples? All right, then your practice for today is going to start on page 464 again. Want to do number 9. 14 through 16. And then over on the next page, 18 through 20, or actually just do 18 and, yeah, do 18 through 20. And then 29 and 30.